Hey everybody, welcome to your first lesson in Unit 1 for Math 1. So the beginning part of the lesson is going to go with the lesson overview notes that are in your note packet. And this goes with lesson 1.1, identifying terms, factors, and coefficients. And in your notes packet, at the very bottom right, it says U1-7. The beginning of Math 1 is really making sure that we have a solid foundation in our algebra skills. And so some of this might be review for some of you, but we're also going to be going deeper with it and doing more word problem style questions and real life applications. So the introduction really goes over how thoughts and feelings and language those are conveyed through expressions, right? But in math, those same kinds of ideas, mathematical ideas, are conveyed through algebraic expressions. And I know you guys have heard of expressions and equations before. Expressions is something like 3x minus 4, which you see at the very bottom of this, the last sentence, or second to last sentence. Whereas an equation would have an equal sign. So that's how you can remember the difference between the two. Expressions don't have an equal sign, as equations do. And so variables in expressions and equations are letters that are used to represent values or unknown quantities. And those can change or vary. So again, the expression 3x minus 4, the variable is x. And you will see that right here. The variable is x. So expressions are made up of terms. A term is a number, a variable, or the product of a number and variables. And an addition or a subtraction sign separates each term of any expression. So there's an expression, 4x squared. So right here, 4x squared plus 3x plus 7. So you notice there are three different terms. The terms are 4x squared right here, 3x, and 7. And again, the terms are separated by addition or subtraction signs. In this case, they're both addition. So those are the things that kind of chunk up your expressions. The factors of each term are the numbers or expressions that, when multiplied, produce a product. So in the example above, the factors of 4x squared are 4 and x squared, because you can multiply 4 times 1 to get 4 and x times x to get x squared. And then in 3x, the factors are 3 and x. And you multiply 1 by both of those to get that. 7, notice, does not have a variable attached to that. And we'll get to that in just a second, what that's called. So 4 is known as the coefficient of the term 4x squared. The coefficient is the number that comes before a variable when they're not separated by a positive or a negative sign, a plus or a minus. Coefficient is the number multiplied by a variable in any algebraic expression. So the coefficient of 3x is 3. So we've got coefficients, those are numbers, and variables, which are letters. And then the term 4x squared also has an exponent. So we've got a couple of different vocab words going on. We've got coefficient, and coefficient is a number. We have got exponent. Exponent, that is the thing that tells you how many times a factor is being multiplied itself. So in this case, 2 is the exponent, and it means that x is multiplied by itself 2 times. And then terms that don't have a variable, which we said earlier was that number 7, it didn't have any letter attached to it, those are called constants because the quantity doesn't change. You're never going to change the number 7 when it's just by itself. When you have a variable next to a coefficient, the variable x could stand for anything, in which case that's going to change what the other number is. Okay, so here's a little bit of a review. So we've got an expression. It's the same expression we've been working with. It's 4x squared plus 3x plus 7. And the terms, remember, the terms are separated by the plus or minus sign. Okay, so we've got 4x squared as a term, 3x is a term, and 7 is a term. Factors are things that can be multiplied out. So we've got 4 is a factor, x squared is a factor, 3 and x are factors. But notice that there's not a factor here because there is no variable here. 7 is just 7. So 7 so far is a term, and that's it. Coefficients are your big numbers. So we've got a big number here, and that is a number that's attached to a variable, a big number attached to a variable. We've got a big number 4 and a big number 3. And then constants are your numbers that do not have variables. So our number 7 is the only one that's a constant. So terms with the same variable raised to the same exponent are called like terms. So we have another example. In the example, 5x plus 3x minus 9. So you're looking for like terms. And in middle school, you guys definitely did combining like terms. So this might start to ring a bell. So we are going to look for things that are the same and that are raised to the same power. In this case, we've just got 5x. It's raised to the first power, but we don't write the little number 1 out, so it's just 5x. So you're going to look for any other coefficient that has an x attached to it. And we've got a 3x. 9 does not have a variable, and so 9, remember, is called a constant. So 5x and 3x are like terms. Oops, I'm learning how to use the highlight tool, y'all, and I'm practicing, and that was kind of messy, so bear with me. All right, so like terms can be combined following the order of operations. So please excuse my dear Aunt Sally. And you evaluate grouping symbols, exponents, multiplication, division, addition, subtraction. So in this example, we're going to just add, because there's an addition sign, 5x and 3x, which is going to be 8x. In what we've gone over so far, the most common errors and common misconceptions are not correctly following the order of operations. And remember, order of operations again, please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. Other common errors are incorrectly identifying like terms. So saying 4x squared and 5x are like terms. Those are not actually like terms because they do not have the same, they're not raised to the same power. This has a 2 that's raised to the second power, and this, remember, when anything's raised to the first power, you don't write it in, but if we did write it in, whoops, I don't want laser pointer, I want pen. If we did write it in, it would be first power. Notice those are different, so you cannot combine them. And then incorrectly combining terms involving subtraction. So this is really practicing our knowledge of using integers. So anytime you have anything that is like negative 4x minus 5x, if you were combining those like terms, you're always going to circle the coefficient and the variable with the sign that goes to the left of it. So the negative 4x goes with 4x, and the negative 5x goes with 5x. Remember, when you combine means add. When you're adding two negatives, you're just going to have a bigger negative number. So you're combining negative 4x and negative 5x. You're just going to ask yourself, what's 4 plus 5? That's 9. X, because the variable doesn't change and your sign is negative. So that would be the answer. The sale price of the smartphone is $149.25, and you've got plus the discount. The discount is 25%. So there are two terms described in this expression. So the question asks us to identify the terms. The sale price of $149.25 and the discount of 25% off the list price. So your two terms in this are going to be 149.25 and 0.25x. Now just pay attention just for a minute. What's the difference between these two numbers? What does one have that the other does not have? A variable. 149.25 does not have a variable, so remember what that's called. Next, we're identifying the factors. 0.25x is the only one that has a variable, so whenever you're identifying factors, 0.25 is a factor and x is a factor. If it doesn't have a variable, there are no factors to identify. Now we're going to identify coefficients. 0.25 is multiplied by the variable x, therefore 0.25 is a coefficient. So 0.25 has an x attached. Anything that has a variable attached, that big number that comes before the variable is your coefficient. And last, identify any constants. Remember, the constant is the one that doesn't have a variable and it doesn't change. So our $149.25, look at my highlighting skills, y'all. This is awesome. That is our constant. Okay, so here we go. We're going to plug them in. 149.25 and 0.25x are the terms. Those are just the chunks of things on either side of your addition or subtraction sign. Here are the factors, coefficients, and constants. So we've got Helen purchased 3 books from the online bookstore and received the 20% discount. The shipping cost was $10 and was not discounted. And we're writing an expression that represents the total amount she pays for 3 books plus the shipping cost. So we've got number 3, we've got 10 and 20. Okay, so here we are. We have got 3 books plus shipping is 3x minus the 20%, and you have to multiply that by the 3x again because she's getting 20% off of each book. So she bought 3 books, and then the plus 10 is independent because the $10 is the shipping cost that was not discounted. Notice that there is a subtraction sign here. The subtraction sign is super important when you're setting up expressions rather. In this case, it means discount. When you get a discount, it means you're paying less for something. This is the cost of shipping. She has to pay it, and so that's why that one, it's not very clear. That's why that is an addition sign, because she's paying $10 for shipping. Looked at this to identify our terms. Remember, you look at what is separated. Let's see. All right, sorry guys, I had to get my pen. You look at the numbers that are separated by your addition and subtraction signs. So in this case, we've got 1, 2, 3 terms, but it asked us to simplify the expression first. And because of that, in the end, after we simplified, we only have 2. Now we're going to identify the factors. Well, only one of them has a variable, and so that's 2.4 and x are the factors. And then coefficients, only one has a variable, and the number that is with the variable is your coefficient, so that's 2.4. And the constants, remember, that's the one without the variable, and that's the number that does not change in the expression, and that's the number 10. I hope you guys have really enjoyed your lesson. Again, we'll do example number 1 together, and feel free to go back to any part of this. In your notes, please write anything that was confusing. Make sure that you have done your annotations on the first part that didn't really have anything to fill in, the first 2 pages, because that's going to be really valuable for you when you're going to do your shelf work and all through your explores and expands, extends, and all of your studying that you'll do. Yay, have a great day, guys.